Hello. So what we're going to be going over today is the balancing of combustion reactions. Okay, because of the fact that we've got so many oxygens, it sometimes gets a little difficult or strange on what the math looks like. Trying to find out how many I have on one side versus how many I have on the other. So I've developed this, or I've seen this technique that works. So the first thing that we're going to talk about is an alkane. An alkane is a type of molecule which follows this general formula, okay, where C is carbon and hydrogen and H is hydrogen. Now, this can be found on table 7, on page 7, table Q, okay, and if you notice, there is the formula there. So what this is designating is that if we have a particular number of carbons and apply the combustion formula to it, the combustion reaction to it, we're going to be able to take care of all types of combustion reactions. So let's go ahead and start. So let's just say, for example, and we're going to start a little right off the top, n equals 8. So if n equals 8, that means I've got 8 carbons. So we're going to go ahead and start the chemical reaction simply by plugging in that 8. So if n equals 8, we have C8, and then our hydrogen, and 2 times 8 is 16, plus 2 would be H18. Now we're going to go ahead and apply a combustion reaction to this, and by that I mean that we're going to add oxygen with the products always being carbon dioxide and water. That's how you know it's a combustion reaction. So we're going to head and we're going to fill that out here. We're going to add our oxygen here. Put our arrow. Put a blank in so we could add our coefficient later. And then it's always going to give us a product of carbon dioxide and water. And that's how you know it's a combustion reaction. Now this happens to have 8 carbons. So the prefix for a organic molecule with 8, which can again be located on the same page, different table P. For the organic prefix there for 8 would be oct. So as in octagon. So this is actually called octane. Octane. So if n equals 8, we have octane, which is in gas. So we're actually looking at the combustion of gas here in a way. And anyway, so with that said, let's go ahead and try to solve this. So the first thing I'd like to do is balance my carbons. Okay? That's the technique. Let's go ahead and balance our carbons. So if we have 8 carbons here, and we've only got 1 there, we're going to go ahead and put an 8 there. Okay? Next, I'm going to go ahead and I'm going to look at my hydrogens, and I note that I've got 18 hydrogens here. In order to fix that on the right side, what do I need to do? Yeah, multiply this by 9. So now I've got 9 times 2, because again, the rule of thumb is we add coefficients and we multiply subscripts. We add coefficients and we multiply subscripts, okay? So now I'm going to stop. And I'm going to do a little bit of this trick math per se. So I'm going to go ahead and I'm going to see how many oxygens I have in each of these molecules. So first I've got 8 times 2, or 16 oxygens, or O's, there for the coming off of my carbon dioxide. And then in the same breath I've got over here, I've got my waters, I've got 9 times 1, or 9 oxygens off of my water. Combined, I've got 25, right? 16 plus 9 is 25 oxygens. So what I'm trying to get at here is that I've got 25 oxygens currently on this side. So let's take that 25 and let's literally just put it here. Alrighty? And then let's go ahead and multiply the entire equation by 2, except for what we put in the oxygen. So that this 2, this 1 now becomes a 2. This 8 now becomes 8 times 2, which is 16. This 9 is also multiplied by 2 and now becomes 18. Now I'm going to look at this equation and I'm going to say to myself, can I divide everything by 2? I could divide this by 2, but I can't divide 25 by 2 and get a whole number. That is telling me that now this equation is balanced. Let's make sure. 2 times 8 is 16 carbons. 16 times 1 is 16 carbons. Carbon looks balanced to me. 18 times 2 is 36 hydrogens. 18 times 2 is 36 hydrogens. That also looks like it's good. We mentioned that there are 16 times 2. 16 times 2 is 32 oxygens on this carbon dioxide. And then 18 times 1 is 18, which comes out to 50 on this side, or on the product side. So we've got 50 oxygens here, and 25 times 2 is 50 oxygens here. And so our oxygens balance out, and we have a balanced chemical equation. Alrighty? There you go.